Okay, here we go. So, example one. The advisor of an ecology club in a large college believes that the group consists of 10% freshmen, 20% sophomores, 40% juniors, 30% seniors. And I goofed when I wrote the problem, so I'm changing it to a random sample of members for the club this year consisted of 14 freshmen, 19 sophomores, 51 juniors, 16 seniors. We want to test the conjecture. So when we're looking at this, what we want to actually look at, all right, the counts, the actual club are your observed, okay? And when I added 14, 19, 51, 16, I got 100 just because it'll make our problem easier. So we're expecting 10% of this 100 to be freshmen, but we actually got 14 freshmen. We're expecting 20% of this 100 to be freshmen, but sophomores, but we actually got 19 sophomores, if that's making sense. Our hypotheses look different. Okay, and I wrote the parameter this time, but these problems, we don't actually really need to write the parameter because we kind of do it in the hypotheses. Our null hypothesis is you write out what your percents are. So we're just going to take our expected percents and we're going to put it in the context of the problem. The ecology club is these percentages. Your alternate hypothesis, you just say at least one proportion is not stated as above. Okay, we don't have to get into specifics. Don't try to figure out which one it's not going to be right. Just say at least one is not as stated. Then when we do our assumptions, okay, we got to check to see it was stated that it was a random sample of the members of the club. Good. Population. This is a little unrealistic when I made this problem because it's unrealistic that there's going to be 1,000 club members. But I don't know. Maybe we're talking like something nationwide, and then that would make sense. All right, and then we want to make sure that all of our expected counts are at least 5. I'm going to show you that in a minute. So I usually write it here because we use phantoms and it makes sense, but then I just write see chart below. But if you write this and you don't do the chart below, then this doesn't count. All right, you got to write it. So what I did, the name, chi-squared goodness of fit test, all right, and then we say, okay, test statistic. What we're going to do is I'm going to make this little table. You don't have to make this table, but you do have to organize yourself somehow. I wrote down my observed from the original problem, okay, and then my expected. I expected 10% of the 100 to be 10. I expected 20% of the 100 to be sophomores, so that's 20. 40% of the 100 to be juniors, so that's my 40. That's why I made it 100, just so it's nice and easy to work with the numbers. Then your formula, remember, it was chi-squared equals the sum of O minus E squared over E. So I'm going to take each problem, like each category, freshman, 14 and 10, here's freshmen. Okay, sophomores, 19 and 20, here's my sophomores. Then my juniors, then my seniors. You type this in one shot in your calculator, the whole thing. Okay, don't forget the squares. People love to forget the squares. Then you get your chi-squared answer. All right, this is always going to be positive because these values are always being squared.